In the silent frost between the stars, where suns appear only as distant embers, and time drifts without meaning, something ancient began its long approach toward our sun. Not a craft, not an engineered beacon, but a shard of another solar system's youth, a relic forged in the cradle of a star we will never see. Astronomers would later name it 3I Atlas, the third confirmed visitor from interstellar space. But almost immediately, observers noticed something unsettling. This traveler did not behave like anything in the catalogs of planetary science. Its chemistry, its structure, its awakening, all defied expectations. And when NASA finally revealed what it had seen, quietly and with unusual urgency, it sparked one of the most heated scientific debates of the decade. On November 19, 2025, NASA did something rare. It called an emergency briefing. No warnings, no scheduled updates, no slow build-up. Just one reason. New images of 3I Atlas captured at the moment of its closest pass around the Sun, its perihelion, during a period when Earth was completely blind. The alignment of the solar system had turned against us. From October 29, the comet slipped behind the Sun from Earth's viewpoint. Every ground-based observatory, every optical telescope, even space telescopes near Earth, all were blinded by the solar glare. But while Earth lost sight, something remarkable happened elsewhere. Across the inner solar system, instruments that had never been meant to study comets suddenly turned their gaze toward one object. Mars orbiters, Mars rovers, solar monitors, even asteroid missions, an entire armada of spacecraft, scattered across millions of miles, recorded a single interstellar traveler. This had never happened before. Not for a comet, not for any known object born around another star. To understand why the response became unprecedented, we must go back to the beginning. July 1, 2025. The Atlas Sky Survey, a system designed to detect hazardous asteroids, spotted something moving unusually fast across the background stars. A new object, bright, and on a course that made orbital calculations hesitate. Its path was unmistakably hyperbolic, too fast to be bound to our sun. It was not returning. It was not captured. It was simply passing through the solar system after a journey lasting millions of years. Within days, astronomers confirmed what many had hoped but few expected. This was the third visitor from interstellar space ever observed. The first, Oumuamua, had blurred the line between natural object and something stranger, tumbling and accelerating in ways that still raise questions. The second, 2I Borisov, behaved like a typical comet, a relief to many who preferred clean explanations. But 3I Atlas? It broke the pattern entirely. It was large, unusually bright, and already active at distances where comets are expected to remain silent. It behaved partly like a comet we understand, and partly like something no model accounts for. Everything hinged on perihelion. The moment the sun's heat would strip away the comet's outer layers and reveal its core nature. But Earth could not see it. The geometry of the solar system placed us on the far side of the sun. If humanity missed that window, we would lose our single chance to witness what an interstellar object becomes under stellar fire. Instead, the solar system itself opened its eyes. Mars Reconnaissance Orbiter, the closest image ever captured from 19 million miles, the Mars Reconnaissance Orbiter redirected its high-resolution camera. For a moment, Mars, the world it was built to study, became secondary. The orbiter captured what no spacecraft had ever recorded before: a close-range optical image of an object born around another star, a nucleus glowing fiercely, wrapped in an uneven veil of dust. The shape was asymmetric, almost sculpted, as if the sun were carving it into something new. Scientists watching the raw data described the moment as surreal, a world built by humans orbiting Mars, photographing a wanderer built by physics in a distant solar nursery. NASA's MAVEN spacecraft used its ultraviolet spectrograph to examine the coma. What emerged from the data stunned researchers. A massive hydrogen envelope expanding into space, the unmistakable fingerprint of water ice sublimating from within the nucleus. These were water molecules forged around another sun, released into vacuum after a journey across the galaxy. For planetary scientists, the detection was almost poetic, the chemistry of a foreign star system now drifting past Mars. On several nights in October, cameras aboard the Perseverance rover tilted upward toward the thin Martian atmosphere. They recorded a faint, luminous streak drifting across another planet's sky, a visitor older than Mars itself. A robot on one world had photographed an interstellar comet passing overhead. Historians will speak of this moment long after 3I Atlas has vanished into darkness. Punch, watching the solar wind sculpt a visitor. Wide-field imagers from the Punch mission captured the comet interacting with the solar wind in real time. Its tail bent, stretched, and thinned, a dynamic structure shaped moment by the flow of charged particles streaming from the sun. Stereo, a stranger in 3 dimensions. The Stereo spacecraft provided multi-angle views, allowing scientists to reconstruct the comet's evolving structure in 3 dimensions. The results showed rapid mass loss and complex jets unlike typical solar system comets. SOHO, a veteran, observes the unfamiliar. SOHO, which has discovered thousands of comets over 3 decades, finally observed one not from our solar system. Its coronagraphs revealed a brilliant, active coma shedding enormous quantities of dust and gas, more than early models predicted. Even with unprecedented data, something didn't fit. 3I Atlas was simply too active and too early in its approach. It produced strong jets far from the sun, distances where interstellar comets should remain frozen and silent. It looked fresh, as if it had recently been torn from its original star system. But the anomalies deepened months before perihelion. Hubble's teardrop mystery. Hubble images from July showed a teardrop-shaped coma, highly asymmetric. Typical comets develop rounder shapes unless strong localized jets are dominating the outgassing. This was not normal behavior. Something inside the nucleus was venting in a focused, powerful way. Not all astronomers interpreted the data the same way. One of the strongest voices was Professor Avi Loeb, former chair of Harvard's astronomy department. He did not claim the object was artificial, but he insisted that scientists avoid assumptions. He pointed to several unusual features. Activity levels too high for an object that spent millions of years in interstellar space. Spectral lines with subtle differences from classic comet models. A trajectory that produced nearly ideal viewing geometry for multiple spacecraft. Morphology that defied traditional categories. His message was simple: do not assume nature is simple, prove it. NASA's response was careful and measured. According to officials, all available evidence pointed to a natural comet. Pointed to, not proved. And that small distinction kept the scientific conversation alive. On November 16th, astrophotographer Satoru Murata captured one of the clearest images yet from Earth. Multiple, long, streamer-like tails. A green coma glowing with diatomic carbon. Fine structures rarely seen even in active solar system comets. 3I Atlas was shedding itself into space in elaborate, dynamic patterns. It was not a silent visitor. It was a world tearing itself open under the sun. Even if every anomaly finds a natural explanation, 3I Atlas remains scientifically priceless. For the first time in history, humanity obtained close-range images from Mars orbit, ultraviolet chemistry from MAVEN, surface-level photographs from Mars itself, continuous views from multiple solar observatories, multi-angle tracking across millions of miles. This is the template for how future interstellar objects will be studied, and Earth's moment is about to begin. On this date, 3I Atlas will reach its closest approach to Earth, around 170 million miles. close enough for large observatories to obtain high-resolution spectra, mid-level telescopes to resolve tail structures, amateur astronomers to record detailed images, atmospheric and thermal models to refine mass loss estimates. Scientists hope to analyze isotopic ratios revealing the temperature of the star-forming cloud where it was born, complex organic molecules forged in another solar system, brightness variations caused by rotation, potential fragmentation events, any unexplained acceleration or spectral oddities. What Mars and solar observatories have already seen. Earth will observe with greater clarity. This is the closest humanity has come to performing a complete interstellar autopsy, a full chemical and structural examination of a foreign world. After December, the object will begin its escape. It will cross Mars' orbit, then drift past Jupiter, Saturn, Neptune, until the Sun's gravity loosens its grip and 3I Atlas slips once again into the cold void between the stars. It will carry scars from its passage, fractures carved by solar heat, water vapor stripped away, dust lost to the solar wind, organics flung into space. For millions of years it will wander, a dark ember drifting through unknown regions, and perhaps someday it will enter another star system. Perhaps another civilization will detect it, measure its chemistry, debate its anomalies, never knowing that once, in a distant corner of the galaxy, another civilization watched it too. We are living through an era that once belonged to science fiction. We can now detect interstellar travelers. We can study them from multiple planets. We can debate their nature, their chemistry, their behavior. We can coordinate a solar system-wide observation campaign, something no generation before us could even imagine. 3I Atlas reminds us that the solar system is not closed. It is open to the galaxy. We live in a cosmic ocean, where debris from ancient suns drifts freely between star systems. This visitor came from far beyond the sun's reach. It entered our space. It revealed its secrets in plumes of dust and gas. And soon, it will fade into darkness once more. But its legacy, the images, the chemistry, the debates, the insights will remain. This is what it means to be a civilization awakening to the wider galaxy. We look outward. We question everything. We accept mystery over certainty. And we learn from the travelers that cross our sky. 3I Atlas came from the stars, and in its brief encounter with our sun,